Hello everyone, welcome back to MTT. I want to say thank you, sincerely a thank you, for just watching and supporting that last video. I think it's at 80 views right now, as the last time I checked, and like 8 comments. And I just want to say thank you so much, really. Like, I didn't expect it to even probably get over 10 views, and to even get any more than like the 4 people I told about this channel, the 4 subscribers I had. And going into making this video with 12 and like over 80 views, that's such an accomplishment. Really, I thank you all so much for just seeing that video on a lot of people's recommended and just clicking on it. Really, thank you so much for being here, and I just hope that I complete my end of the deal and give you guys the best informative stuff that I can give you guys from my level. So without further ado, today's video we're going to be talking about networking essentials, and it's going to be an overview of computer networks. So this is a part of a bigger series of networking essentials where I'm going to go over these concepts that are essential to networking, and this is just an introduction into the bigger picture of networking. I'm going to introduce some concepts in the simplest form so that way you guys can get a basic understanding, and later on in other videos, if there's something that I'm kind of missing out on, it's because I'm going to be getting more in depth on some specific aspects where there is more to know, and that will be touched on later. So if I'm missing something out, if I'm missing out on something, just know that it's going to be touched on later, and this is just a surface level video. So without further ado, let's get into it. Today we're going to be covering what is a computer and its functions, what is a computer made up of, what is a network, what do networks do, what are networks made up of, how do these components work together, and what kind of networks are there, and then some closing thoughts. So let's start it off with what is a computer and its functions. A computer is a device designed to accept, process, and execute data. That's the 3 primary functions right there. And we can see that through desktops, laptops, tablets, and smartphones. Now, a computer isn't just these 4 things. There's many other things, such as even a smartwatch or like an Amazon Alexa. Those are also computers, but they're what's it called? Specific computers. I have the word later on in this, and I'm gonna get to that in a second. So what does that mean? What it means to accept, process, and execute data is that, let's say someone told you to clean your room. What are some steps that you would take? So to accept, process, and execute the data to clean your room, I'll probably take out the trash, fold my clothes, make my bed, sweep, vacuum the floor. And now, while all of these steps are correct, computers process tasks in a very important order based on the task at hand. This set of steps is called an algorithm. An algorithm, once again, is a series of steps based on the task at hand. An algorithm for cleaning the room might look like opening the door into the room, walking into the room, identifying dirty clothes, placing dirty clothes in a basket, identifying trash, throwing the trash away, locating the bed, picking up the bed sheets, folding the bed sheets, laying out the bed sheets, locating the pillows, pick up the pillows, arrange the pillows, placing them down. Now, we can see how tedious this can get very quickly, but luckily for us, our brain can do this faster. And the same goes for the computer's brain, also known as the central processing unit. Now, what is a computer made up of? And if you know, you know. This is a motherboard, which is going to be the video after this in the series of networking essentials. But so for this purpose, we're going to be defining what a desktop is made up of, because if you can understand this, all of the concepts kind of go by really smoother. So we're going to be defining what is a desktop made up of. So the components of a computer are designed to perform any of the 3 tasks: input, processing, and output. Some devices that make up the input side are going to be keyboards, mice, microphones, webcams, USB ports, and hard drives, among many other things as well. Some processing devices are going to be the central processing unit, the brains of the computer, like we mentioned before, graphics processing unit, GPU, and network interface cards, the NIC. Output devices are going to be seen through screens, monitors, projectors, speakers, printers, LED lights, and hard drives. Now, these components are connected to the motherboard in one way or another. And motherboard, once again, was that like little green thing with all those pieces on it. If you aren't familiar with it yet, don't worry, we're going to get into that later in another video. And whether they are built into it or attached as external devices, Any order to be processed and executed goes through the CPU. So now, if there's anything school taught me, is that the mitochondria is the powerhouse of the cell. And the same goes for the CPU. If the mitochondria is the powerhouse of the cell, providing energy to keep everything running, think of the CPU as the powerhouse of the computer, processing instructions and managing tasks to keep the system functioning. So now with that said, now that you know what a computer is and the kind of 3 primary tasks, let's get into what a network is in its simplest terms. So a network can be seen kind of like through these pictures. A network is going to be a collection of connected devices such as computers, servers, routers, and other hardware. I know those are new concepts. We're going to get into that very shortly. But, so, it's a collection of connected devices that communicate with one another over either airwaves or cables to share data, resources, or services. And keep in mind that it's either airwaves or cables. So, what do networks actually do? So now that we know a network is a collection of connected devices that communicate with each other, what do they do? So networks allow for the communication through airwaves or cables. So now picture this. You work in an office building and you need to print out a document, but the printer is going to be all the way down on the other side of the office. Rather than searching the office you're in for a USB, downloading the file that you want to print onto the USB, walking over to the printer, realizing you forgot to grab the USB, then walking back to your office, getting the USB, going back to the printer, putting the USB into the printer, trying to figure out how to print and walking back to the office. This is a situation that it happens to people. It's very real. And networks, all you have to do is open the document, click the print option from the menu, and walk to get the paper. Mission accomplished. You know, the days of having to scramble around and do this, it's almost no more. And some places you might still have to, but it should be just with the network. Just click print from the menu and you're done. So now, for this example, what would you say was the medium used? Airwaves or cables? And the medium just being the interconnecting device. Was it airwaves or cables to connect the desktop to the printer? Okay, so if you said airwaves, you'd be correct. Due to the printing room being located across the office, running a cable just wouldn't be ideal. Connecting the printer to the office's network and having the desktops on the network also allow for communication, and in this case, an easy way to print. So if you got that right, good job. So what are networks made up of? So these are going to be the components of a network. Networks feature specialized printers such as routers, switches. Can I move myself? Okay. Networks, switches, servers, modems, as well as desktops, laptops, printers, and smartphones. Now, this isn't everything that a network is made up of. There's more devices, but for this slide and for this video, these are just going to be the 4 concepts that I'm introducing. So, a router. A router connects your device to the internet and helps them communicate with each other. So, a router connects your device to the internet and helps them communicate with each other. Switches. Switches help devices communicate with each other on the network more efficiently by sending the data to the device is intended for. It's done through these little ports right here. Your devices are connected into that, and if the device right here has a message for this device right here, rather than sending it through this one, then 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 this one, it can know, and it can send this device to the desired port number all the way over here. That's going to be a video for another day, but let me just introduce that now. Servers. A server is a computer that stores and manages data and services and sends it to the device when they request it. So once again, a server stores and manages data and services and sends it to devices when they request it. Think of like Google, all of that stuff. Those are huge servers that store everything on the internet. And when someone types in www.google.com, they're requesting that information. So just think of a big database. Modems. Let me move myself again. The modem takes a signal from your internet provider and converts it into a digital signal that your devices use to connect to the internet, typically through the router. So once again, the modem takes the signal from the internet provider, makes it into something that your devices can understand to connect to the internet, and that signal is then given to the router. So now that you know that, how do those devices work together? So it's gonna start off with the modem. The modem's gonna bring the internet into your network. I just said this a few seconds ago. Now that we have connection from the modem, what does that go into? The router. Using the internet provided by the modem, the router shares the internet connection with devices on the network. Now this one could be a little bit tricky. Now that we have internet in our system and it's connected to devices, what's next? It's going to be the switch. Switches allow local devices within the network to communicate with each other. Now, there's only one option left. It's the server. So now that everything is within a network, the server is going to store the files and websites among other things and provide it to the devices on the network when it's requested. So now this is like a mini network we see here, and how the pieces fit like a puzzle. If you don't have one in this situation, you don't have a network. So each device in the network plays such an important role in just making that good system. So now, what kind of networks are there? There are many types of networks that surround us. Below listed are just some common examples that we can see daily and how they differ from each other and the purpose that they serve. So, a wireless local area network, WLAN. The purpose of a WLAN is to provide wireless connectivity within a localized area, such as a home, office, or public space, allowing the devices to access the internet without needing physical cables, communicate with each other through sharing files or printing documents, and supporting mobility, so users can move freely around without wires, so they can stay connected to the network. Now, we see this especially in homes. Your home most likely is a WLAN, and this next concept is gonna just kind of expand on that. So a wide area network, a WAN. The purpose of a WAN is to connect multiple smaller networks like LANs or WLANs over large geographical areas such as cities, countries, or even globally. It enables communication between locations like video calls, emails, or file sharing between offices in different cities or countries, and it provides internet access to devices by connecting to the global network, allowing users to access websites, online services, and data centers. So even the internet is a wide area network. Now, wide area network is, you got to think big picture, talking continent, globals, countries. Much smaller is going to be the metropolitan area network, the MAN. The purpose of a MAN is to connect networks within a city, metropolitan area, or campus. So, a MAN connects networks in a city or a large campus for fast local communication. It shares resources and services like centralized servers between locations in the area, and it's cost-effective networking. Organizations can use a MAN to avoid using a WAN. So, if you're on a large campus or in a city, rather than having to set up a big thing such as a WAN, you can just set up a MAN, a metropolitan area network. The terms are funny. So, yeah, rather than having to pay for all of that stuff to get the WAN, just set up a MAN, and it can save you so much more money. And the last one for this video is going to be the virtual private network, the VPN. The purpose of a VPN is to provide secure and private communication over the internet. It keeps your internet activity private by encrypting your data. And encryption is just it kind of scrambles the message, so that way when it gets sent across the internet, no one can just look at it. The person you're sending it to with the key, they can look at it, but no one else, which is very important. And it helps bypass restrictions, letting you access content or websites not available in your location. You see that by like Netflix. A lot of shows or movies won't be available in the United States, but they'll be available in the United Kingdom, and vice versa. So setting up a VPN and setting your location to the United Kingdom to watch those shows not allowed in the US would be a great way, and a VPN is useful for that. And it allows secure access to a network remotely, so it allows you to work from home. So now, here's some closing thoughts. This is what we learned so far in this video, and I hope that you take all of this away from this video. What are the 3 primary functions of a computer? If you said input, processing, and output, you are right. So what is an algorithm? This is stuff at the beginning of the video, so like 10 minutes ago. I hope you guys paid attention. An algorithm is a set of steps or instructions the computer follows to complete a task. What is the brains of the computer? Think mitochondria. The central processing unit, the mitochondria, the powerhouse of the computer. What is a network? A network is a collection of connected devices that communicate with each other. What does a router do? It connects the devices on the network to the internet. What does a switch do? Although it doesn't give internet, it allows the devices on the network to communicate with each other and sends it to the desired device. What does a server do? Well, that wasn't much help, but it stores and manages data and services and sends it to devices on the network when requested. What does a modem do? It converts that signal given by your internet provider into a digital signal to your devices used to connect to the internet. How do these devices work together? Now this question is just asking the order. So what would be 1, what would be 2, what would be 3, and what would be 4? Think of the red arrows. If you said modem to the router, to the switch, to the server, you'd be correct. And what would be the ideal network for a house? Once again, you want to think VPN, WAN, MAN, or WLAN, the wireless local area network. So what would be the best for a single house? If you said WLAN, you'd be correct. What would be the ideal network for a large campus? The metropolitan area network, the MAN. What network connects entire countries? If you said WAN, wide area network, you'd also be correct. Now, for the final question, I hope you guys paid attention. If you guys went 1, 2, 3, 4, 5, 6, however many questions this is, if you went perfect, let me know in the comments. If you wanted to watch a show not available in your region, what would you use? If you said VPN, round of applause. So this is just a little overview of what we learned today. I hope that this was new to you guys, and you guys left this video knowing something that you didn't know before going into it. Or if you did know it, I hope that I explained it in a way that you also understood. So if this was something that you guys liked, I just want to thank you for watching. And once again, if there is something that I kind of skipped out on, don't worry, because I'm going to cover that in further content in a further video in the series on specific devices within a network. And I just want to thank you guys for watching. If you enjoyed this, like, comment, subscribe, and I'll see you guys in the next video. Bye.